Okay, YouTube, in this video we're going to work through a subset of these exercises that you see here in order to kind of illustrate how we could use reference angles to evaluate for trig function values instead of using the original angle that we're given in each of these relationships. And so the way this is going to work is essentially we're going to break this down into kind of a three-step formal process. But let's go ahead and start with this. Step number one is going to be to find the reference angle. So we want to know the reference angle for the given angle on any of these that you see here. So we'll say find the reference angle for the given angle. And then the next thing we're going to do is we're going to evaluate the trig function for the reference angle. Basically, we're going to use the reference angle instead. And the last step here is going to be this. It's going to be to determine the sine of the trig function value depending upon the quadrant that it terminates in, okay? And so essentially, let's go ahead and take a look at this first example you see here is number 33. It says, let's go ahead and find the cosine of 150 degrees. So I think the idea is that when we consider 150 degrees, when you sketch this, is going to be over here in the second quadrant, and it's roughly right there, we'd say in this neighborhood, 150 degrees. The idea is that step number one says we want to use the reference angle instead. And so our reference angle here, which is this shortest angle between the terminal side and the x-axis, would have to be a 30-degree angle here. What this means is we're just going to rewrite this as instead of cosine of 150 as cosine of 30 degrees. So now all we need to do is evaluate for the cosine of 30 degrees. Now the nice thing is if you know your unit circle or you know it well enough to reconstruct your first quadrant and the four quadrantal angles, it's going to make our job fairly easy here. So with our unit circle, let us recall that the radius is 1, meaning this is the point 1, 0, this is the point 0, 1, this is the point negative 1, 0, and this is the point 0, negative 1. And then we're going to construct our 30, our 45, and our 60. And these are really the only three that we need to construct here because of the symmetry that exists in this unit circle. But what we know is for the 30, 45, and 60 angles here, our cosine and sine respectively, all of these are all over the value of 2. So we say over 2, they're all halved. And then what we end up with here is, at least with our x values here, we say 1 square root of 2 square root of 3. And then going back up the other side, we have 1 square root of 2 square root of 3. So with these values here, basically what I want to indicate is that we can find the cosine of 30. That's just the x value at 30 degrees right here. And it looks like the cosine at 30 is just this root 3 over 2. So I'm going to go ahead and write that. Now the only thing we have to do is fulfill this third step. And the third step basically says, okay, well depending upon the quadrant you terminated in, should your value be positive or negative? So the idea here is that if we know this mnemonic, all students take chemistry or calculus or however you want to remember it. Basically what we know is that since our angle terminated in the second quadrant and we're finding cosine, our cosine value should be negative because the only thing that is positive in the second quadrant happens to be sine. So we really get negative root 3 over 2. So that was with just using reference angles. So let's try this again. Number 34, the sine of a 225, I just want people to see this here, a 225 would live right over here in this neighborhood, 225. So we want to know what's the reference angle. Step one, find the reference angle. And so by visual verification here, we can see that our reference angle, theta prime, is 45 degrees. What we're going to do is we're going to rewrite this sine of 225. We're going to rewrite it as the sine of 45 degrees. So now we just need to know the sine of 45 degrees. And you can see how knowing this first quadrant here is going to tell us the sine value. Remember the sine value on the unit circle is the y value on this ordered pair. So we get the square root of 2 over 2. So now the only other question we have to ask is, should this be positive or negative? Step 3 here. We have all students take calculus. This terminated in the third quadrant. So the only thing positive down here is tangent, meaning that since we found sine, and sine is not tangent, then its value here has to be negative. So we get negative root 2 over 2. So let's look at one with a tangent value here. A tangent of a 315. We'll go ahead and sketch it out. Now a 315 kind of splits the difference between a 270 and a 360. That's where our 315 lies. So sketching this angle in, again, let's go ahead and find our reference angle. And it's easy to verify again here that our reference angle here is 45. So what we're going to do immediately is we're going to rewrite this instead of the tangent of 315, we're going to say it's the tangent of 45 degrees. So our tangent of 45. Now, remember that the sine and our cosine values are given by x and y respectively on our unit circle here. That's our x and our y. But when it comes to tangent, a couple of identities. First of all, that the tangent is the sine divided by the cosine, but also that the tangent value, if we want the tangent value, we have to take the y value divided by the x value, which really is the sine divided by the cosine. So with respect to a 45, if we wanted the tangent of 45 degrees, we would have to take the tangent of 45 degrees here. We would have to take the sine at 45, which is root 2 over 2, divided by the cosine at 45, which is root 2 over 2, which is the same as multiplying by the reciprocal, root 2 over 2 times 2 over root 2. Everything cancels here, and we just get left with 1. So our tangent value out here is 1. We're going to say that our tangent value here is also 1. It's just that with our sketch that we see here, all students take calculus. The only thing positive in the fourth quadrant is cosine. So we just have to make sure that we call our tangent value -1. So with respect to the rest of these, some of them are in radian measurements, some of them are reciprocal functions. What I would like to do is look at a reciprocal function, okay? Perhaps the secant of 3 pi fourths here, and look at how we would treat something like this. So with respect to secant of 3 pi fourths, first of all, because it's a reciprocal function, what we're going to do is we're always going to immediately rewrite this as the reciprocal of its reciprocal function. So we have 1 over the cosine of that very same angle. So now, all we're responsible for doing is now going and finding a reference angle for this 3 pi fourths. So 3 pi fourths, we can imagine that 3 pi fourths would be, if this was 4 pi fourths, 3/4 of the way there, 3 45-degree rotations. So here's our 3 pi fourths angle. What we see here, though, is that our reference angle, theta prime, is just a pi fourth. So what we're going to do is we're going to take this now, we're going to rewrite this as 1 over the tangent of its reference angle. And so I got to ask you here, the tangent of pi fourths, we kind of just looked at tangent of pi fourths up here when we took the tangent of 45, it was 1. So we get 1. So the last thing we have to do, you guys, is this. Here's my sketch. All students take calculus. Because our angle terminates in the third quadrant here, let me kind of blockade this off. The second quadrant, the only thing positive up there is sine, and we just determined tangent in the second quadrant, which means this tangent value, it has to be a negative value. So our overall value here came out to be the reciprocal of -1, or 1 divided by -1, which is just -1. So with respect to, say, this last one here, the cotangent of negative pi fourths, we would want to say that this is 1 over the reciprocal function of negative pi fourths. So thinking about negative pi fourths, the interesting thing about negative pi fourths is we would have to rotate clockwise pi fourths. It would just be this right here, negative pi fourths. The thing here that's weird about it, though, is that its reference angle is a positive pi fourths. Remember, the reference angles are always positive. So what we're going to do instead is we're going to do 1 over the tangent of just a plain old positive pi fourth. And the tangent of pi fourths, again, is 1. So we get 1 over 1. So we just get 1. So using reference angles, you can see how we could just find a reference angle, use the reference angle instead just by knowing these quantities or values in the first quadrant, and then suppose, depending upon which quadrant it terminated in, assign the SIGN sign that we need on our value. Cheers.